drilling. So today we're going to be talking about the state of digitalization in drilling and blasting. So a super exciting topic. We're going to be kind of looking at this from a high level and also kind of digging down into what this really means in a more tangible way. So to get us started, I'll do a quick intro on Strayos, just for anyone who's not familiar with who we are. So Strayos, simplest way to put it, is a mine-to-mill AI platform. So we have a set of tools and modules and AI algorithms that help with design, mining design, prediction, assessment, and optimization. So examples in the design bucket are things like 3D photogrammetry tools. So you can use drones to make 3D models of your pit, of benches. From there, within the cloud platform, you can then do drilling design, loading design, timing design, drill and blast focus tools there. From that, we can do kind of automatic predictions based on your design for fragmentation, muck pole, shape, vibration, these kind of things, as well as a set of AI-based predictions, kind of using computer vision around slope, stability, rock mass, jointing, things like that. And finally, once you've blasted, we also have AI tools that measure fragmentation and automatically measure muck pile movement, create sections, things like that. Analyze, measure while drilling data, vibration, all these other kind of things, automated haul road analysis as well. And finally, with all these design, predictions, and assessments, we have modules that tie all this data together to allow you to identify trends and optimize for the future. So that's just a quick background on Strayos. As Kim mentioned before, I'm Brad Gingell, COO, mining engineer by background. So without further ado, I'll kick off into the real topic of today's webinar. So we're going to cover, firstly, just the opportunity for digitalization in mining. So just framing this in, why this really matters. Then we're going to go into a little bit of kind of research that we've done based on what we've heard from surveys that we've conducted, and also just from what we've heard in the field from our experience. And then show you how we've developed a framework, a tool for kind of classifying the digital maturity of drill and blast operations. So this is something that we'll go through and also use to explain kind of where we are today versus where we're going. Next, we'll talk about how we're actually, how the best way is to get there. So what are the key pillars for success? And then finally, we'll step through just a little bit of an example around fragmentation optimization to really bring it to life. All right, so let's get started with the opportunity for digitalization. So basically, it's a huge opportunity, and not just technically, but from a commercial standpoint. So back in 2015, McKinsey did some research. There's a pretty widely quoted report that digitalization in the mining industry could provide around $370 billion worth of value by 2025. And the really interesting thing when you look at this, if you guys can read that, is that the bulk of this value comes from improvements in operations management. So at its core, operations management is really taking data to make better decisions. So at the heart of it, digitalization is a key part of this operations management. It's all about data, collecting it and using it. And the cool thing is, and I think part of the reason why that paper identified so much value is because all of the technology individual ingredients have been proven, have been built, have been used in other industries. All the pieces are there, we just have to put them together, which is a bit more challenging than it sounds, but at least we know that that it can be done. So we have kind of three categories of technology. There's the data capture and sensing technologies. So we have drones, we have LiDAR sensors for trucks, we have belt scales, we have sensors for throughput, power draw, continuous monitoring on plant, fixed plant as well. So we have all of this, and what that really does is it feeds data into these data management and analytics platforms, which is the second bucket. And these already exist too. We have cloud, very well developed cloud infrastructure now. That's super simple to set up for anybody these days, and it's also become a lot easier to build machine learning algorithms on top of that, and other statistical analysis algorithms. Finally, then there's a kind of category of technology which is more hardware based, which is more control system based, which is putting things to practice in reality in the physical world. And this is, things like autonomous drilling, autonomous trucks, these kind of things. This is also something that we're seeing is being proven out. So as we said, it is now just a matter of putting these things together, tying the data across these different pieces of technology in order to claim that massive amount of value that was predicted. However, recent research from BCG found that mining is still, this is 5 years on from that McKinsey research, is mining industry is still lagging quite significantly to other industries. So they're still 30 to 40% less digitally mature. And a lot of this is due to this massive gap between strategy and execution. So it's kind of, well talked about in mining circles, in corporate offices now, that everyone knows that digitalization is a huge thing. But when it comes to actually capturing value and delivering on the digital initiatives, that's where things are falling over. And this is something that I guess we've found. So this is getting into a bit of our research from our surveys that we've done through things like this. When you look at the drilling and blasting in landscape in particular, if you look at how many people are using digital, even just digital tools for drill pattern design, the largest answer there is special projects only. Some people are doing it never. Add those two up, that's half the shots that are happening are almost half the sites are almost never doing things digital. It's all pen and paper still. So huge opportunity there. Gathering data on the conditions before blasting, often the best thing is just a visual inspection of the face, the most detailed information. And finally, the implementation of more advanced tools like AI, half people not using it at all yet. A lot of people have just kind of started dipping the toe in the water. So still a huge amount of room for improvement, especially when it comes to drilling and blasting. And here are two insights that we've kind of gathered and put together based on what we see through the companies that we work with, is that overall this level of digitalization, it varies quite a bit based on a whole heap of factors. In general, you have mines being further advanced than quarries. You have larger companies being ahead of smaller companies. These things make sense. You have kind of bigger, once you have bigger budgets, there's more at stake. So you have more people focusing on this stuff. And then finally, countries with relatively heavy mining presence tend to be more advanced. Again, fairly intuitive. None of this stuff is surprising, but it's worth pointing out that it does vary quite a bit. Second thing is really the interesting part. So the factors that we've noticed that are controllable factors. None of these ones in the first point are really that controllable. Second ones, these are things that you can change. These are the things correlated with higher digitalization. So firstly is having site leadership that's really focused on the entire value chain. So you see definitely at some sites, drilling and blasting being treated as kind of an outsourced activity. It's not the focus of site leadership. Site leadership are focused on, maybe the processing plant. Maybe it's, more loading and hauling. It sometimes doesn't quite, the focus doesn't quite get all the way up to drilling and blasting up the value chain. Sites that have this kind of leadership from the top that is thinking across the entire value chain, much more likely to be considering digitalization. Also, alignment of commercial incentives with contractors. So it's key. I guess it's the same with the last one, having strong data infrastructure and sharing that data with contractors. Just that openness and alignment of incentives is key, because most drilling and blasting is working with contractors, whether they're just supplying the bulk explosives. It's still their trucks coming to site most often. And there's always got to be collaboration there. So putting this together into a framework for how to assess where a particular operation is, we've developed a scale, basically drill and blast 1.0 to 4.0, classifying the drilling and blasting activities into three main buckets. So you have your design activities, your implementation activities, things in the field, and then your reporting kind of management activities. So to talk through this, on the design side, so 1.0, this world is, you're laying out with tapes. There's potentially a paper plan or no plan, and probably no loading or timing plan before you've actually loaded and fired the shot. Moving into 2.0, you're starting to do digital design work. So you've kind of pre-designed loading and timing on the computer. Moving into 3.0, it's where you're actually starting to do some optimization on this design. So you're not just designing it in isolation from other shots. You're looking at past shots, what happened. You've maybe built an Excel model with results and design parameters, and you're starting to get to the point where you're making better decisions based on previous shots. And then 4.0 is where this process isn't happening in Excel. This is happening in an automated way using AI that's taking into account many or all of the variables that are available from all the different data sources to make that optimal decision without the human user having to do any extra work. Next, if we come to the implementation phase, we're looking at, in 1.0, analog control drills and trucks, moving around based on site, looking at maybe painted rocks, things like this, to know where to go. 2.0 is where you start bringing in things like GPS, so smart drills. We have smart trucks as well that have maybe tablets that are storing information on what should get loaded in each hole. 3.0, we start having drilling happen from command centers. So remote drilling, making the operators more efficient. And we start having trucks that are integrated. So it's the information that's about what's being loaded into each hole is dynamically updating with some kind of cloud-based database in real time. Then moving into Drill and Blast 4.0 world, though, that's where these things really start happening as autonomously as possible. So autonomous drilling, something that we have seen in action already. Loading is definitely far behind that, but will be coming along progressively, which we'll talk about in a little bit. So this is kind of where you head from that 1.0 to 4.0 world in the implementation phase. Next, looking at reporting. So in 1.0, we're talking about just the only reporting we do is for compliance. So shot reports, maybe it has the vibration monitors information. We have drill logs, but that's it. Just what's required. In 2.0 world, we're looking at someone taking that data in Excel, maybe making manual charts, which is then shared throughout site, which is tracked. 3.0, the data is integrated. That's a bit of a theme across Drill and Blast 3.0. This is when data starts being integrated. And that enables things like real-time dashboards, trends to be automatically identified, things like that. Next, coming into 4.0, so what does that end state really look like? That's where this real-time data isn't just being tracked and reported, but it's actually being modeled with AI, and it's then able to spit out prescriptive insights and recommendations for not just design, but also operational decisions. So this is kind of the state of Drill and Blast across that, where we are today, which is kind of that 1.0, 2.0, getting into 3.0 world, towards that 4.0 world, where a whole lot of value is unlocked. And this might seem, ambitious, I guess, to some of you. Maybe you're in the 1.0 world. Maybe you're moving into 2.0. But I guess I put this up here to challenge us all to start thinking more broadly about heading towards this 4.0 world and thinking, how is what we're doing creating value? So a lot of this 1.0 to 2.0 is maybe reducing some manual work. Maybe it's going into digital shot design, going to potentially improve results, but it's hard to track by how much. Moving into 3.0, again, maybe it's efficiencies. It's having kind of quicker access to data. But where the real value lies is once we start being able to integrate all this data and then make better decisions with it, which is where we move into this 4.0 world, which unlocks that $370 billion of value, or at least the drill and blast portion of that. So that's what I wanted to leave you guys with on this. Then wanted to ask a poll question. So just for everyone who's here today, let me start this off. Where on average do you think you guys are? I think, you obviously say, oh, maybe I'm a 1 in design, a 2 in implementation, and a 3 in reporting or something. Just average out where you think you are today, and answer this in the poll section. You should be able to see it in the chat. Nice, we've got some people in the 2 world, in the 3 world, in the 1. Seems like the bulk are in the 2 at the moment. There we go, getting a few more answers coming in. Yeah, a lot more now. So yeah, definitely bulk in the 2. Hey, we got one in the 4. That's good. Like to see that. We'll have to chat afterwards. Nice. I think they've settled out now, so I'll close it down. But yeah, definitely good to understand where we all are. So next, let's go dive a little deeper into these 3 areas and what that 4.0 world looks like and how we get there. So we have in the design row, that 4.0 world, if you remember, was about AI powered design. So what does that look like and how do we get there? So basically, AI powered design means capturing all the variables that can influence your blasting, capture all the variables that that are results of your blasting that you may want to optimize for, or put constraints against. And it means capturing those in a really integrated way into a continuously learning AI model. So the way to think about this is that every time a design happens, just to bring this to life, that design is automatically synced with your cloud AI model, so that those parameters that really matter can be automatically extracted, pulled into a data. I don't want to say lake here to be cliche, but basically a big table with all of your for all your blasts, all your historical blasts, which can keep building this model, making it more and more accurate over time. And if you're capturing things like dig rates, crusher throughput, the things that really are connected to costs, and you're also capturing those costs, at the end of the day, you can just do a big optimization where you say minimize costs subject to these constraints of, achieving, vibration less than this, achieving, air blast less than this, whatever other constraints you might have, and have a model that continually gives you the best design parameters to use. Jumping to implementation. So in implementation world, as we're talking about, it's much more about autonomous operations. So I guess what I wanted to touch on this one is that with the drilling world, we're seeing this in use now, especially with rotary rigs. There are fully autonomous systems, definitely in use for more than the last few years, and now we're starting to see down the whole rigs that are fully autonomous as well. And it's basically the OEMs is progressing down smaller and smaller, and it's really up to them to enable this, to drive this automation push. The other thing that's kind of coming along with drills is measure while drilling as a data source. So drills being able to capture data about rock hardness, and basically any other geophysical property that you can infer from the way that the drill interacts with the rock. And this is something that is almost like dependent now on having better and better interpretation algorithms. So there are a lot of different proprietary algorithms out there that companies are developing. Everyone's keeping them relatively, in-house. But in order for this to really enable that fully integrated world, we're going to have to start seeing more integration across the drilling and blasting value chain. So even if it's not making those algorithms public, it's still the output of those algorithms having to be able to feed some design software, which can feed a control system on a truck, for example, so that based on whatever the drill encounters in the rock, that can specify a certain product to be loaded, which the truck can just automatically load without humans having to be involved in that decision-making process. On the loading front, so obviously automation and loading are much more complex, but I did just want to highlight that, some of the components from a technical perspective are potentially there, in terms of putting GPS on the end of an auger. There is self-driving technology, rapidly advancing in other areas. Obviously, a lot of safety concerns there on a bench with boosters and things lying around. So, not saying this is something that's going to happen. Just saying that the components are there. It's something that's worth thinking about how we work towards, especially with the other complexity being how do you prime holes without a human, and wireless debts really being the only answer there. That the earliest wireless debts are available on the market now, even though they're initially rolled out for underground, being used in open cut as well now. So those are definitely there that exist. So more saying here that the technology components are starting to get there, but yeah, not making any promises that will get to an actual autonomous state anytime soon. On the reporting side, here's where I think the key message here is that, like we've been saying, like having things be integrated is really the key, and it's the thing that it's the key for is kind of progressing from being able to make monthly decisions on things to being able to make real-time decisions. So if you think about some things that are reported on monthly, anything that's reported on monthly just enables a monthly decision. If you report on something daily, it enables a daily decision. If you're reporting on something in real time, it enables you to make better real-time decisions. So think about the things in your operations that are reported monthly at the moment. There are some questions that are fine to be at monthly level, like cost forecasting for the month. Maybe we don't need to be doing that in real time. And these things are possible to do, with just a person aggregating the data at the end of every month. For daily decisions, though, when you think about, superintendent, planning for the day, planning for the next day, things like, are we going to have to bring another drill in here? Should we switch the product for this next shot? These kind of decisions, you can make them with data that's being manually aggregated, but it takes a lot of manpower to chase this data down if it's not integrated, if it's not just at your fingertips. And this is where integration can start to bring some of these decisions that are just being made by gut to be made by data. Finally, the real-time decision making. This is where integration really becomes key. When you have things like a fully integrated design system with a truck control system, if you come up to a hole and it's collapsed or it's different, or it's angled and you didn't realize it was going to be angled, it wasn't supposed to be, you know exactly how to load it if that truck is fully integrated with the design system. Real time, which holes have been loaded, exactly how many holes have been loaded, where the problems are, to know if you're going to be able to fire on time. And also just operational data, so if you're going to, if it's worth, as a production superintendent, sending a loader somewhere else instead of waiting around for this shot to be fired, if it's likely that this shot's not going to get fired today. Same thing with the drill. You make better decisions around where to send a drill if you have immediate real-time information on what's going on. So those are some of the, that's Drill and Blast 4.0. We talked about some of the benefits of getting there as well. So next we're going to talk about how to get there. So what are the key pillars for success for digital transformation. So this is at a bit of a broader level now, but there are 3 things that you really have to get right. So firstly, you have to get the commercial pillar right. You have to establish the right processes for prioritizing the right things. So this is figuring out what to do. Called it commercial because it needs to be focused on value. The second pillar is the technical pillar. So it's, okay, now we know what to do. How are we actually going to design this thing? What's it going to look like? How are we going to develop integrated systems? And how are we going to balance flexibility with being useful for our particular site? The final thing is cultural, which I'm sure everyone can relate to. Building capability and also willingness, which is sometimes more difficult within a company to embrace digitalization. So I'll jump into the next poll. If you let me open this one up. So basically, I just want you all to enter into the poll now. Which of these pillars do you struggle with the most? And let me know if you can't see the poll. There we go. Off to a good start with cultural, which I'm not super surprised about. Getting a few in the other categories, but definitely cultural seems to be the clear winner here. I've had 2 clear winners out of 2 polls so far. That's good. A bit of commercial sneaking up, but still definitely dominated by the cultural pillar. All right, nice. I'll close this one off and we'll have a talk about each of the pillars. So I'm just going to give you kind of my quick perspective on some of the issues that I see across these pillars and the solutions to those issues. So this may not be comprehensive and it may not be exactly your problem at your site, but here are just things that I've noticed in general across the industry occur. So basically in the commercialization, in the commercial pillar, the key is to focus on long-term value. So an issue that I've seen some mines have is mines all tend to now have BI systems in place, prioritize things based on ROI. That's great. You know, we're thinking about value when we implement initiatives. But a challenge that always comes up is that it's difficult to say what the ROI is for something that hasn't been done in your particular context, or just hasn't really been done before. You know, every site has all these different parameters. You have your own value chain with your own constraints. It's extremely difficult to estimate what the actual value is going to be for a unique site. The other thing is that a lot of initiatives are kind of in the form of enablers that if you did them on their own, they wouldn't really produce much ROI. So a lot of the setting up the data infrastructure, for example, it's not until you then put the other applications on top of it that you then get the value. But it's difficult to know where to put that. So these are just some of the challenges I see people face, especially, you know, when you're an engineer and, you know, you don't want to be, you know, this isn't where you want to spend 8 hours a day on. This is something that you want to get through quickly so that you can get to actually implementing the solution. So the solutions that I've seen to this that work are essentially building these longer term roadmaps. So mines from the very top have to have leadership focused on identifying a relatively succinct set of long-term initiatives that are the most valuable, and then work backwards from that. And that way you're going to capture the enablers in these long-term initiatives and not going to have to be worried about justifying them individually. Next, an ROI estimation and tracking should take into account the full impact on value chain. So you need to have at least some kind of value chain model so that just ready so that you can value what the impact is going to be of making changes to any one part of the value chain. And thirdly, you have to maintain focus and not be kind of diverted to looking at other shiny objects. Next, we have the technical pillar. And in this one, a lot of issues, if we think about kind of like the traditional way of developing technology and implementing technology, is that a lot of companies, the kind of default thing to do is to go in-house, custom, own everything, build everything. And I guess the result is that you don't have something that's designed to be integrated with a whole lot of other different systems. And therefore, often you get into the case where you spend a long time developing something, and then as other technologies come along and certain other pieces change, you end up with something that's no longer fit for purpose. It's not delivering the value that you thought it would. It's much more complex than you thought it would be, doing a lot of custom integrations later. And then the other thing the other challenge in the tech lever is pillar is that skills shortages just make it really hard to do things quickly. It's just a reason for this being slow. It's there isn't a lot of crossover between the mining and tech worlds. So solutions, they sound obvious, but it is hard to keep these front of mind when the rubber hits the road, is to always be testing quick to deploy solutions before building custom things. Test things with MVPs. See if there's an off-the-shelf option first that you can just take, implement, prove the value, and build out from, as long as it's extensible. Secondly, build the tech architecture in a modular way, rather than everything being built only for the other components that exist at the time. Try and keep everything connected to a single source of truth for data, and build things in a way that they can be subbed out later on. And then lastly, make sure for every module, every one of those modules, you're doing a rigorous and ruthless evaluation on whether you should build it yourself versus buy it versus borrow it. Make sure that there's not something easy out there that you can take and use, and make sure that you're taking into account speed to develop it, capability of the team, how custom does it really need to be for your particular circumstance. Now, finally, on the cultural pillar, which is definitely everyone's favorite, is, I guess, the key thing is build with the field. So don't just build for the field, build with the field. Get people involved. So don't build tools that that are really great technically, but create more work for people, that create another experience, another interface that people have to engage with. Embed everything into the existing day-to-day processes of people on site, to have the strongest chance of adoption and engagement, which will give you the strongest chance of achieving sustained value out of these initiatives. An issue is that things are often managed and developed centrally and then kind of rolled out, which can lead to a lack of buy-in. I'm sure everyone's been there, and we all try and involve people. But really the key is taking a human-centered design approach, working with people in the field to actually co-develop solutions that solve their frictions and their particular issues that they're facing in their role, So to bring this to life, it's not having an AI algorithm that spits out an answer in a form that's completely different to how it needs to be inputted into the blast design, or an AI algorithm that tells you that you need to only do 2-row shots when it's just impossible at a site that's like a gold mine or something like that. So make sure that everything is coming out, is not just being spat out into a number that someone has to interpret and then and go and incorporate into what they do. Have it be coming out in a format that solves a problem for them. So find out where they're having their problem, where they're looking for it. It's like, is it midway during their design process, and what form do they need that answer in, and deliver it then and there from an experience perspective. And secondly, always incorporate this agile implementation. So make sure that you have cross-functional teams with people in those particular jobs, in small units that are empowered to make decisions on the design side. So we're now just going to walk through an example of how this could look for fragmentation optimization. And I'll just do the last poll real quick, talking about what kind of fragmentation optimization is everyone doing at the moment. So just want to get a sense of are people kind of actively looking at this? How many people are actually measuring fragmentation? Are people doing kind of these one-off consulting type studies? Or does anyone actually have fragmentation data being, continually fed into a model? Nice, we have a few people. Still mostly with one-off studies, but starting to even out a bit, which is really interesting. Seems like at least a good portion of people are focusing on fragmentation. Got at least 70% of people who are doing some kind of measurement of the impact of fragmentation, which is great to see. So I'll shut this one off and then we'll step in. So an example of applying this framework and applying this thinking is you might start with a commercial lever, do a whole bunch of analysis on what are the opportunities that are out there, and then prioritize them based on what are the largest value pools to start with, because we want to think long term, and what's actually applicable for our sites. And maybe the answer to that we find is that fragmentation optimization impacts the largest value pools. So it's a hypothetical, but generally fragmentation optimization hits quite large value pools for, unless it's maybe like cast blasting in coal, there's probably not much that is a larger value pool than this, because this can affect your entire revenue value pool if you can increase throughput, because your crushing and grinding step of the value chain is often the bottleneck. If fragmentation can improve the capacity of the bottleneck, then you've increased total site throughput. You're just getting more revenue. You also are impacting crushing and grinding costs, which that's a huge portion of costs on site. If you take into consideration consumables from mills, take into account electricity or energy, generally the biggest cost on site, you have a massive value pool of cost there that you're also hitting as well. So once we've identified fragmentation optimization as something that we're really keen on addressing, we might go out and look at, well, what are the technologies that we need to get us there? And this is just looking holistically at, if we had this perfect solution, what do we need? We look at the data capture and sensing side. We can use drones. They exist. Lasers exist. Measure while drilling data sensors exist. Having designs be digital and having quality control be digitized as well. That's That's something that exists. We can do that. We can pretty much get all of the data that we need without having to invent anything, build anything ourselves from scratch. Next, we look at data management analytics. The cloud data management infrastructure, that's easy to get now. Maybe there's some customization setting it up, or maybe you go to a provider that already has this set up for drilling and blasting for fragmentation analysis. But yeah, this is something that exists off the shelf. No need to build this from scratch. Same with a lot of the AI algorithms for parsing some of that data that we captured. And then finally, implementation for doing things like actually customizing loading to rock type, things like that. We have variable density and variable energy charging available now, offered by the major OEMs. We have bulk chuck control systems which are able to be integrated. So this stuff exists. We can, maybe all these things aren't put together in a neat package that you can buy, but all these pieces exist. So now coming to that cultural pillar, the important one is, how do we actually embed this into user workflows? So we're not just building something which is creating additional work. We have to really think carefully about who are the stakeholders that we're impacting at each step of the process, and what does their workflow look like, and how can we integrate with that workflow? So data capture, we have maybe the surveyors, drillers, engineers doing this. They can leverage things like automatic drone flights, or at least autopilot apps to control drone flights, so that there's not much that has to be done. Maybe the drone is filming the shot already. It's very easy to set up an autopilot so that as soon as it's filmed the shot, you just press the button and it goes and then takes a few photos of the muck pile that can be used for fragmentation analysis. Measure while drilling data, so basically, communicating with the smart drill, you can set that up so that's happening over wireless. Just the less human touch points, the better. Same with plant sensors. So, there are third parties that provide sensors that you can stick all over, fixed and mobile plant to measure, dig rates, crusher throughput, things like this. And those can all be integrated with your cloud system. So making sure there's you can take the human out of the equation there. On the data analysis step, so it's how do you make sure that you have AI models working that are able to continuously learn and then spit out data into kind of automated dashboards without having someone in Excel going and aggregating this data later on. In the design step, which is really one of the most interesting ones, is how you get the optimization results delivered within the design software so that it makes sense and can be used without the person designing the blast having to interpret it. So how can you have the software immediately know what the contextual conditions are in terms of bench geometry, rock types, MWD results, and then automatically design the blast better based on that. So you don't have a person there having to go and figure out all this data, give it to the AI model, get the results back, and then try and plan it in the context of the of their own 3D model. And then finally, actually implementing it, so drilling and charging. How do we get these drill plans communicated wirelessly to smart drills? How do we get loading plans synced to truck control systems? These are things that that are proven already exist now. So that's kind of where we have to think in terms of embedding it so that people in the field really adopt it. Make it as easy as possible for them, make it solve their problems, not just add work for them so that we can create value somewhere else. But that's the dream state. Where do we get started? We need an MVP. And how do we think about designing an MVP? So it has to be something that's quick to set up and create early value, because the point of it is to prove early value and fund the rest of the project. But we want to do it in a way that's extensible. We don't want to build an MVP that we then completely throw out. Ideally, we want to build something that works, but it's scalable to build into something bigger. So I'll start from the bottom. But in our MVP world, maybe we use shot report data, plant performance data, and nothing else. Just the numbers, just the number for burden and spacing that already lives in our shot reporting system. Just daily plant performance data that already exists, numbers that are already there. We don't have to build any AI models to interpret it. We're just using the numbers that exist. Then we want to build it on. We don't want to just go straight to Excel. We want to build it somewhere cloud-based, because that's not that hard. That's maybe a little harder than doing something on a standalone computer. But that's where making it extensible becomes really important. So even though it's an MVP, let's put it in the cloud. Let's have it, syncing these different types of data if possible, or just accepting them. But at least it's storing them somewhere that can be used, can be extended later to integrating more data sources. Next, when we build the analysis tool on top of it, let's build it. It can be simple. It can just be a regression model to start with, but let's build it in R or some other language, or some tool that's able to be built on later and made more complex later. And then finally, importantly, we've been talking about embedding this into the user experience. Let's have the output of this, rather than just coming out onto through some kind of standalone interface that in a program that people have to install on their computers. Let's have it integrate with existing reporting tools and flow through in the same places that people are already going to access data. So now we've done that, we've set up our MVP, we've then scaled it into a big working embedded solution. Everyone's happy, people in the field are happy. We should all be happy on site, because we're getting massive improvements. So, we're seeing improvements in the range of kind of 5 to 10%, because we're doing things like improving throughput of the bottleneck, components of our value chain. We're seeing costs reduce on the drill and blast side. We're seeing, maybe we've removed all secondary breakage that we're doing as well. We have huge amounts of value being created from fragmentation optimization. And then the other benefit is that the data platform and the AI models that we build for this, we're basically taking in a whole bunch of inputs and predicting results. Those results can also be things, they don't have to be strictly to do with throughput. You can have environmental impacts as well, safety impacts as well. These same models that we've set up for this, especially these kind of visual AI models, monitoring the pit, monitoring benches, can be used for other things, monitoring for slope failure. In the community side of things, we're minimizing vibration, we're preventing damage to sensitive locations, and we're creating new high-skilled jobs. So that's the walkthrough of bringing this to life of fragmentation optimization, and these are some of the benefits that come out of it. So that's been it for today. Thanks, guys, for listening. Not sure if we have time for questions now, or if we'll get to them afterwards. Ravi?
Yeah, we'll take a few more, just a couple of questions, since we're just a minute more into the actual slotted time. But yeah, I think there are some interesting questions, and most of them towards the data and the AI. And so we'll answer one. I think that's my favorite topic here, that I can take up the question that was
go for it.
recently answered, is by Alex. The question is, AI means different things to different people. Is this AI model just a statistical tool doing multivariate analysis? If not, how does the AI work? And I think if you have to, the kind of simple answer is AI is nothing, but just doing an analysis what the patterns that has been identified and the model has been trained. So essentially, it's kind of the involving the programming of the algorithms that mimic human thinking. Um, Such as learning and problem solving. So we ourselves as a human, are much better in understanding the problem and coming up with solution. Same way AI also are trained to do analysis, but it can do in millions of data points and millions of data set, and the scalability is a lot faster there. So these algorithms are trained. The difference between the statistical analysis versus the AI is statistical analysis are still limited on the scaling side. So your algorithms would work on few data sets only, where the differentiation of AI is you can put in any type of data with a scale of 100 times or 1,000 times, and it will kind of expand from there. That's where the true leverage of AI comes in, where you can test every possible combination, not just with a speed, but at speed of millions per second. That's where the statistical modeling gets limited, where you're only testing for a very fixed pattern, and it also has some time variance there. So then there's a few more questions up on the top here. And we understand, I think folks may have to drop, so feel free to drop. There's one good question here from Bill up on the top here. Will the push into DNB 4.0 involve a heavy emphasis on data verification, such as quantity, validity, lack of bias, etc., given the crucial role it plays in AI decision making? And I think it's very true that the data is the key source here, and the more qualitative data you can get, the more contextual it becomes. And we want to drive contextual intelligence. So not only what type of data is collected, but how it's collected, and the quality and the quantity will definitely be given an emphasis as you're moving towards from DNB 2.0 to leapfrogging into DNB 4.0 here.
And I think
Brad, you can expand that.
Yeah, definitely. Like, what will become more important is being able to quantify the confidence in outputs of models, especially in the AI world, where things become a bit more complex, and the actual workings of the model seem like more of a black box to people. Being able to not just quantify it, but communicate it in a way that helps people make better decisions. So basically assessing the output of the models as well as validating the inputs will become really important.
Yeah, we'll take one more last question here. It's from Jack. And in your studies, how much this modeling has been done with non-electric versus electronic?
Yeah, so in this case, it's possible to do either way. Really at the end of the day, the way the models work is optimizing based on whatever input parameters you give it. So you can still test different timing designs using non-L, and you can test non against electronic if you want as well, to try and quantify the benefits of switching to electronics, for example. So yeah, it can definitely happen in either one or across both.
Yeah, I take it back. I think I said last question, but there's a few more interesting questions just came in here from Alex here. Again, favorite question because it just goes to the heart of the AI discussion. The question is, many sites work off rule-based blast design. In order to collect enough data for the AI to start building an algorithm, do you have break these rules to design blast with a wider range of blast design parameters? So I'll just start here, Brad. You can expand on this. There is always this misconception about the AI to work with. You have to have you have to spend several months to collect the data and then put AI into a practice. But actually, AI can start from the very beginning itself. Yes, you have to have certain subset of data from the site to start working, maybe a couple data sets to start. But there are several ways AI can generate synthetic data, which kind of mirrors the other types of scenario and can generate synthetic data sets, which can be used to train the model. So the implementation time not only gets reduced to realize true value of AI. So if you're starting a project where you have a goal in mind to implement AI, it can start from within just a couple of weeks, to a few weeks. And as you get more site data, your models can be calibrated to the actual live, site data as well. But it should not take a, several months long, project to get the true realization of AI.
Yeah, exactly. And there are definitely ways that you can use kind of pre-trained AI algorithms as well to get started. So not just pre-trained on synthetic data, but pre-trained on other data from industry-wide data.
Great. I think we have a good stopping point. There are a few more questions coming up, but we will answer those or email. Definitely, we appreciate everybody here sticking around longer, and thank you for attending here. Brad, any last comments here?
No. Thanks again, everyone, for coming. It's been a pleasure. Feel free to reach out if you have any questions.
Thank you, everybody.
All right. See you.